Flotation cells for employ in a plant have to be chosen based on laboratory and pilot scale data. What we have here are the factors to consider in selecting flotation cell. First is the most favorable grind size of the ore. This depends not only on the discharge characteristics of the ore, but also on floatability. Very coarse particles will be too large to be levitated by attached bubbles, and extremely fine particles will float poorly due to not striking the bubble surfaces, oxidation effects, or other problems. The coarsest material that can be floated is normally around 300 micrometers, while the finest particles are around 5 micrometers. Second is the amount of reagents needed and the appropriate points in the circuit to add each reagent. It is often essential to condition the reagents with the minerals for a period of time to ensure good coverage with collector, and in many cases, adding frother in stages along with makeup water may be necessary to keep the pulp level and froth depth constant. Third is the optimum pulp density. This is needed for determining size and number of flotation cells for a given capacity. Fourth is the flotation time needed to reach desired recover. And here we have a comparison for the time needed for flotation in plant and in the laboratory. And as we can see, a longer time is needed for flotation in the plant than in the laboratory, mainly due to the increased time needed to move through the large equipment. Lastly is the corrosive and wear properties of the ore, which are needed for selecting appropriate materials for the construction of the plant equipment. In this table, we can see the normal number of cells per bank. And to understand more, let's have Chamel Kayabyab for a sample problem.